Hi guys, it's Mr. Ng, and I have a quick and dirty video on how to do those problems about Charles's law. Let's hop right into it. So this problem says that during the day, a 27-degree cylinder with a sliding top contains 20 liters, and then at night it only holds 19 liters, meaning it cooled down a bit. So what is the temperature at night? Well, let's go through this handy list of things to do. Let's first convert to kelvins. Here we have a temperature 27 degrees Celsius, and let's not have it in Celsius. Let's have it in kelvins. To do that, we say 27 plus 273. That's kind of the magic conversion here. We just add 273 to it, so that's actually 300 kelvins. Done and done. And scanning the problem, nothing else needs to be converted, so let's move on. Done. Let's write the equation. V1 over T1 is equal to V2 over T2, right? This is the equation that we've been going over the last few days. So now we just have to figure out who's V1, who's T1, and so on and so forth. Let's go through our numbers. Our very first number is 300 kelvins. So that's the temperature that the cylinder was during the day. That's our beginning temperature. So instead of writing T1, we're going to write 300 kelvins. And then with a sliding top containing 20 liters, that's our beginning volume, because volume is always in liters. So I'm going to write 20.0 liters here, right? That's substituting V1. And then at night it only holds 19 liters, so that's going to be our V2, 19.0 liters. And I don't have any other numbers, so T2 is the thing we got to solve, which makes sense because it's asking what is the temperature. Right, so to solve, I'm just going to cross multiply, right? So it says that T2 times 20.0 liters is equal to 19.0 liters times 300 kelvins, right? To isolate this variable, we want T2 to be by itself. Let's divide both sides by 20 liters. I'm going to divide you by 20 liters. All right, so here 20 liters cancels. Here, check this out. The liters will cancel immediately, meaning we're going to be left in kelvins. This is a great little way to check to see if you've set things up correctly. So now we just have to solve. So it's 19 times 300 divided by 20. And I got 285 kelvins. All right, so T2 is equal to 285 kelvins. Right, and done. We have the kelvins done. It also wants us to report the answer in Celsius, so that's very easily done. So to do that, it's just 285 minus 273. All right, so that's 12. 12 degrees Celsius. 12 degrees Celsius. Done. Let's do one more. So this problem says a 113 liter sample of helium at 27 degrees Celsius is cooled to negative 78 Celsius. Calculate the new volume. Okay, let's convert some stuff into kelvins first. This is not 27 degrees Celsius. This is actually 300 degrees kelvins. How did I do that? Well, it's 27 plus 273. And here, negative 78. It's just 273 minus 78, and I got 195. So this is not negative 78. This is 195 degrees kelvins. Again, if you're wondering how I did that, I just did negative 78 plus 273 is equal to 195. Or if you could switch the digits around if it messes with your head and just do 273 minus 78, same thing. Okay, so I got my conversions done. Right, these guys I will use later. Let's write the equation. V1 over T1 is equal to V2 over T2. Right? Next, let's plug in. Let's see, V1, 113 liter sample is cooled, and calculate the new volume. So this has to be V1, right? It's in liters, and it's the first thing. 113 liters. T1 is the starting temperature, and that thing was at 300 kelvins. All right, and then it's cooled to 195. That's got to be T2. That's a temperature, 195 kelvins. And when they want us to calculate the new volume, meaning V2. All right, now all we got to do is solve. So I like to do a little cross multiply first. That's just the way I live. I start with a cross multiplying. I could just multiply both sides by 195, but I like to cross multiply. So V2 times 300 kelvins is equal to 113 liters times 195 kelvins. Let's divide both sides by 300 kelvins. That way I could isolate the variable. I want to know what V2 is. Get out of there, 300K. Come over here, 300K. If you notice, the kelvins cancel out. So long kelvins, hello liters. So V2 is equal to 113 times 195 divided by 300. And I got 73.45 liters. We only have 3 sig figs, it looks like, maybe 2 sig figs. So I'm going to say 73 liters. That is our new volume. I hope that helps. And good luck on your quiz tomorrow. Thanks for watching. Bye-bye.